In this problem, we'll see how to solve a system of 3 linear equations. Let's look at our helpful hint. Try to eliminate one of the variables from the original first and second equations. Then eliminate the same variable from the original second and third equations. The result should be a system of 2 equations in 2 variables. Here we have a system of 3 equations, and the helpful hint tells us to first look at the first 2 equations and eliminate one of the variables. Probably the easiest thing to do to eliminate one of the variables here would be to multiply the second equation by -2 and then add together to eliminate the z. So I'm going to leave the first equation alone and just rewrite it. And with the second equation, I'll multiply through by -2, giving us a +2 here, which will give us an opposite coefficient as in our first equation. Multiply by -2, so -4x minus 6y plus 2z equals 4. And now if I add those equations, I'll get -x minus y, -2z plus 2z is 0, equals -1. So now we have an equation with x and y only. The helpful hint then tells us to look at the second 2 equations and eliminate the same variable. So the way we would do that is multiply equation 2 by 6 and have opposite coefficients on our z again. So I'm just going to rewrite equation 3. And then take equation 2, multiply by 6. That will give us 12x plus 18y minus 6z equals -12. Adding here, we get 14x plus 22y equals 6. Now we have a system of 2 equations with just 2 variables that we can solve. I'll write that right over here and bring this over here. Now to solve this system of equations, we again want opposite coefficients on either x or y. I'm going to multiply the top equation by 14. I'll get -14x minus 14y is -14. And I'm just going to rewrite this equation right below. And then adding together, our x terms drop out. -14y plus 22y is 8y equals -8. And now we can solve for y and find that y is -1. Now we can take our value that we just found for y and put it into one of these equations to find x. We just found that y equals -1. Now let's find the value of x. We can use either one of these equations to substitute the value for y. I'll use the second equation. So we'll have 22 times -1. 14x plus a -22 equals 6. Adding 22, we'll have 28 on the right. And then dividing by 14, we'll see that x is 2. So we have our value for y. We just found our value for x. Now we can take both of those values and substitute them into one of our original equations. And we could choose any of the three. I'm going to choose equation 1 and substitute these two values in. So we'll have 3 times 2 plus 5 times negative 1 minus 2z equals negative 5. So 6 plus negative 5. And here we have a 1, 6 plus negative 5. And then finally subtracting 1 from both sides, and then dividing by negative 2, we will see that z is equal to 3. And we can write our solution this way, or we could write an ordered triple. And that would be our x value first, y value second, and z value third. So remember, when solving a system of 3 equations, eliminate one of the variables from the first 2 equations, then eliminate the same variable from the second 2 equations. This will result in a system of 2 equations in 2 variables.